He appears first as a faint correction in the night sky, a tiny point of light that does not quite belong where the charts say it should. Under a soft glow of starlight, telescopes track a dot sliding across the dark like a slow brush stroke. The name comes later, 3I/Atlas. But before the numbers and letters, he is just an unfamiliar motion against the fixed stars, an ancient traveler stepping into the frame. Astronomers notice the shift the way you might notice a stranger standing at the edge of a quiet room. A small change. A drifting shadow. Nothing dramatic at first, just a feeling that something new has entered the cradle of silence overhead. If you are listening to this while you drift toward sleep, you are part of this watching too. These stories exist so you can lie back and look up without leaving your bed. If you want more nights like this, calm journeys through the dark, subscribe and in the comments tell where you are and what time it is. New York at midnight, London before dawn, Los Angeles late evening, Sydney in bright afternoon sun. I read them like a constellation of listeners spread across the earth. 3I/Atlas is what astronomers call an interstellar comet. Most comets are local wanderers. They live in the distant cold of our own solar system, far beyond the planets, where the sun is only a pale lantern in endless night. Every so often, gravity gives one of them a small nudge. Its orbit tips, its path bends, and it begins a long fall inward toward warmth and light. As the comet moves closer to the sun, something gentle but powerful happens. Ice that has been frozen for billions of years begins to wake up. Dust and gas lift off the surface in a slow, steady breath, surrounding the solid core with a luminous haze. From far away, this haze looks like a soft glow, a gentle veil wrapped around a dark heart of rock and ice. We give this visitor a name and numbers because that is what science does. 3I means it is the third confirmed object to pass through our solar system from another star system, an interstellar traveler. Atlas comes from the Survey telescope that first noticed it, a camera scanning the sky night after night for small changes in starlight. In a way, the comet carries its discoverer's name like a quiet tribute. To understand why this matters, it helps to know what a comet really is. At its core, a comet is not magic. It is a mixture of frozen water, carbon dioxide, carbon monoxide, and other ices, clumped together with dust and rock. You could think of it as a leftover piece of a planet that never formed, a crumb from the early days of a solar system. Astronomers track its orbit carefully. They take many pictures, each one a still frame of the night. In every frame, the stars stay in place like a printed map, but the comet moves. With simple math, they turn those dots into a trajectory, a curve that shows where the comet has been and where it is going. When that curve does not loop back toward the sun but stretches outward, open-ended, they know they are not looking at a local visitor. They are watching an object on a free path through the galaxy. Spectrographs add another layer to the story. These instruments take the comet's light and stretch it into a rainbow, then into thin, bright lines and gaps. Each line is like a letter in a cosmic alphabet, telling what gases and elements are present. The pattern might reveal water, carbon, sodium, or other chemicals, each one a clue to where this comet was born and what it has carried across space for millions or even billions of years. When 3I/Atlas enters our view, it is easy to feel a sense of wonder and awe. Here is a messenger from somewhere else drifting into our neighborhood. It has no voice, no written note, but its very presence is a kind of message. Other star systems exist, they form comets too, and sometimes their ancient fragments cross our path. Under the soft glow of its tail, you can imagine worlds unseen, suns too far for the naked eye, and exoplanets circling quietly in the dark. News headlines talk about it as if it is the whole story. The strange interstellar comet. The unknown traveler. The possible harbinger of new discoveries. Artists make illustrations of a luminous object flying past the planets, leaving a shimmering trail. It feels like a main character, the one everyone is watching. But as the cameras follow this one object, something quieter hums in the background, all the things we are not watching. Every dot we track in the sky is chosen for a reason. A telescope can only look at a small piece of the universe at a time, like a flashlight beam sweeping across a wall. Survey programs decide where to point that beam. They scan along the plane of the planets, or across regions where past discoveries were rich. They avoid places too close to the sun's glare, where the brightness drowns out faint objects. This means that our awareness of the sky is not complete. It is a patchwork of observations stitched together over days and years. Between the patches lie gaps, spaces where no one was looking on a particular night, or angles where small objects could hide in the glow of the sun. Our planet spins, the moon moves, the weather changes, and the watching stops and starts again like a slow heartbeat. If you could step back and see the pattern of where we have looked and where we have not, the picture might surprise you. Some regions are dense with data, filled with the tiny trails of known asteroids and comets. Others are nearly empty, as if the universe there were quiet and still. But the universe is rarely still. The silence may only mean that our instruments were sleeping at the time. So while 3I/Atlas moves along its traced trajectory, marked with careful numbers and predictions, there may be other objects taking different paths. Objects that never pass through the narrow cones of our telescopes, or that cross the sky during hours when no one could see. Some might be small, no bigger than a house, turning into meteors if they ever meet our atmosphere. Others might be larger, silent stones sailing through the dark, unknown to us. Our cosmic awareness is fragile because it depends on attention, and attention is always limited. We watch what we know to watch. We point our telescopes toward the likely places, the familiar lanes where past travelers have appeared. Yet the universe is under no rule to send its messengers along those same roads. In the soft dark of your room, this might feel like a distant problem. Numbers, orbits, and surveys far above your roof. But it carries a quiet weight. We live on a world moving through a vast, dynamic space, and our picture of that space is incomplete. Even on the clearest night, when the stars look sharp and steady, we are seeing only a thin layer of the story. 3I/Atlas, the comet everyone is watching, becomes a reminder of both our progress and our limits. We can detect an ancient traveler from another star system, measure its trajectory, sample its light, and predict its path across the sky. That is an achievement for a species that once looked up with nothing but naked eyes and simple dreams. Yet the more clearly we see this one visitor, the more quietly another question begins to form, like a whisper at the edge of hearing. If this is the traveler we happen to notice, what else is moving out there, beyond our charts and beyond our watch, drifting through the darkness where no telescope is looking, carrying stories we may never read? High above the noise of cities, above highways and clouds, the sky settles into a deep blue-black. When night arrives, it looks endless and complete. To the human eye, it feels like everything is already there. The moon, a scatter of stars, maybe a faint band of the Milky Way. It is easy to believe the sky is fully known. But it isn't. The sky most people see is only a thin layer of what is really there. For astronomers, the night is not a flat picture but a moving ocean. Comets glide through it. Asteroids cross invisible paths. Distant galaxies gather in quiet clusters. Each point of light has a journey, a trajectory written in gravity and time. And even with many telescopes watching, large parts of this ocean remain unseen. Telescopes push that idea much farther. Wide-field survey instruments sweep the sky in careful strips. Their cameras blink every few seconds, catching galaxies, nebulae, and faint comets as tiny dots or smudges against the black. Computers compare one image to the next, searching for anything that moves or changes. A drifting shadow here, a new soft glow there, an unexplained speck that was not present the night before. From the outside it sounds simple. Point a telescope up, take images, find objects. But the real sky is messy. Clouds slide in and out of view. The atmosphere bends and blurs starlight. The moon washes half the sky in pale light, erasing the weakest signals. The glow of cities throws a gentle veil over the faintest stars, hiding them behind a human-made haze. Even the best detectors work through noise. So astronomers plan their surveys like careful dances. They choose dark locations high on mountains, far from cities. They time observations around the moon's phases. They point their telescopes away from the brightest part of the Milky Way when they are looking for small, nearby rocks, and toward it when they search for distant clouds of gas and dust. Every choice is a trade. Focus on one thing and something else slips out of view. In the data, that trade shows up as gaps. A telescope that scans the northern sky may never see certain parts of the southern sky. Another that stares deep into a single patch of space may miss everything that moves quickly across a wider field. Nights are lost to storms, to mechanical issues, to simple limits of time. The sky above Earth turns hour by hour, and no single instrument can catch every moment. These gaps are what astronomers call blind spots. Some blind spots are literally bright. Near the sun, the sky is so flooded with light that small asteroids and comets can approach from that direction almost invisible. If a rock comes toward Earth from the region close to the sun's glare, it can remain hidden until it is very close, emerging only when it swings into the darker hours of dawn or dusk. To a ground-based observer, it appears suddenly, like a messenger stepping out of a spotlight and into the dimmer halo around it. Other blind spots are caused by geometry. Objects that share an orbit similar to Earth's can stay near the sun in our sky, always too close to its brightness to see from the ground. Some hide behind the sun from our point of view, like unseen companions walking on the far side of a circle. There are also asteroids on tilted paths, spending much of their time above or below the thin band of sky that most surveys watch. Some blind spots are simply the result of human limits. Telescopes have finite time and limited funding. Survey programs must decide which goals to prioritize: distant galaxies that reveal the shape of the universe, exoplanets that might host life, or near-Earth asteroids that might someday pass too close. Every hour spent chasing one goal is an hour not spent on another. Slowly, a pattern of attention forms across the sky, bright in some places, dim in others. When scientists talk about a visitor like 3I/Atlas, they often show beautiful images: a bright core, a tail stretching like a brush stroke across the sky, a luminous haze wrapped around an ancient traveler. These pictures give the impression that space is well mapped, that important visitors cannot simply slip past us. But the truth is softer. For each well-photographed comet, there are many dim objects we barely see, and even more that we never notice at all. Consider a small asteroid only a few tens of meters wide. It reflects little sunlight. Against the backdrop of stars, it appears as a faint streak, almost like a scratch on a camera sensor. If a cloud passes at the wrong time, or if the image is slightly blurred, that streak may be missed by both software and human eyes. In some surveys, data volumes are so large that no one manually inspects each frame. A possible harbinger may flash through one or two images and then be gone, its orbit never fully measured. And yet, these are the kinds of objects that can cause real effects. A meteor the size of a house can explode high in the atmosphere with the force of a large bomb, shattering windows, startling entire cities out of sleep. A slightly larger one can carve a crater into the ground, reshaping a landscape in seconds. The bigger problem, then, is not a single dramatic comet from deep space. It is the quiet chance that something modest but important might remain hidden until it is almost upon us. Astronomers respond by building better surveys, using more sensitive detectors, and launching telescopes into space where there is no atmosphere to blur the view. From orbit, a telescope can look back toward the inner solar system, watching for objects against the dark rather than the bright sky. Infrared instruments can pick up the heat from asteroids too dark to see invisible light, revealing drifting shadows as warm specks against the cold. Bit by bit, the unseen regions shrink. Yet they never vanish completely. There will always be parts of the sky we are not looking at in this exact moment. The universe does not pause while we set up our instruments. Comets continue along their orbits. Asteroids cross the plane of Earth's path. Distant galaxies send their faint messages of starlight, whether or not a spectrograph is pointed in their direction. Standing under the real night sky, none of that is visible. To most people, the stars simply shine. The moon glows. A meteor streaks by now and then, a brief, beautiful surprise. But behind that simple view lies a more fragile truth. Our picture of the universe is built from tiny, scattered moments of watching, stitched together by human patience and limited by human reach. Somewhere, even now, a small object might be gliding through one of those silent regions. A drifting shadow between beams of starlight, passing through the cradle of silence above Earth without anyone yet aware. And as the planet turns and the stars will slowly overhead, the question hangs there with it. What waits in the parts of the sky where no one is looking? High above the turning Earth, the night looks calm and complete. From a distance, it feels as if every corner of the sky is known. Star charts cover the heavens with neat lines and labels. Orbits are drawn like threads, circling the sun in smooth loops. It is easy to imagine our planet as a well-guarded citadel, a fragile fortress floating in space, protected on every side. But fortresses only look solid from far away. If you drift closer in your mind, you begin to see the fine cracks in our watchful net. There are places where telescopes do not look as often. There are hours when the bright face of day hides the deeper velvet of night. And in those pauses, those gaps between glances, anything small and silent can slip by. Astronomers spend their lives tracing paths through this vastness. When they speak of an orbit, they mean a path carved by gravity, the invisible curve that keeps a comet or asteroid tied to the sun. They take a handful of careful measurements, points of light against the dark, and fit a smooth trajectory through them, like drawing a gentle arc through stars on a page. Over days and weeks, the pattern sharpens. The object's future position becomes a quiet prediction, a line of destiny sketched through space. One special moment in that journey is called perihelion, the point where the object passes closest to the sun. Near perihelion, heat begins to work upon the ice and dust. A once faint speck brightens, wrapped in a luminous haze. Gas escapes as a soft glow, stretching into a tail that streams away from the sun like a gentle veil caught in the solar wind. For a time, the ancient traveler becomes easier to see. Yet vision is more than brightness. Seeing needs both light and attention. Not every watcher uses a simple telescope that just magnifies. Some instruments, called spectrographs, do something more delicate. They take the starlight or the light from a comet's coma and spread it out like a rainbow laid flat. Tiny dark lines and colored bands appear. In those lines, scientists read the presence of water, carbon, metal, or something stranger, like listening to a cosmic whisper encoded in color. But even the finest spectrograph needs someone to notice that there is light to analyze in the first place. Down on Earth, the planet turns. One side faces the sun in bright noon, the other leans into the cradle of silence and stars. Telescopes on the night side open their domes, gears humming softly as they track the sky. Others, placed high in orbit, float above the weather in constant day. They all do their best, yet none can see everything all the time. One of the largest blind spots lies close to the sun itself. When you stand outside on a clear afternoon and look up, you see a soft blue ceiling of air. The stars are still there, but the scattered sunlight fills the sky with brightness. Against that brilliance, the faint shimmer of a small asteroid is almost impossible to spot. Many near-Earth objects that approach from the direction of the sun remain hidden until they have already passed, or until they burst into the atmosphere as an unexpected meteor. From the ground, astronomers rarely point their most sensitive instruments too close to the sun. The risk of flooding cameras with light or damaging delicate sensors is real. So they turn their telescopes away from that glare, and a wedge of sky becomes a quiet unknown. Another blind region hides behind the Earth itself. Imagine our planet as a dark coin blocking the sun. From certain orbits, there is always a shadowed region, an area where small objects can travel unseen, sheltered from direct observation. A tiny asteroid could drift through that space, its path aligned just so, and never cross a place where our main surveys are watching at that moment. The blind spots are not only in space but also in time. Telescopes can scan only so much sky each night. Weather, funding, and simple human limits shape what gets observed. Some surveys focus on known hot spots, where many asteroids have been found before. Others map the same fields again and again to catch subtle changes. Every choice of where to look creates, at the edges, a choice of where not to look. The fortress watches, but it blinks. In those blinks lie the blind spots of our cosmic defense. You can picture them as quiet corridors winding through the solar system. Near the sun's glare, over the bright daytime sky, behind the turning Earth, and in the gaps between survey fields, these corridors form patterns we rarely consider. They are not physical tunnels, but regions in space and time where our attention is thin. If an unknown traveler wanted to pass unnoticed, it would not need active camouflage or advanced technology. It would only need to trace a trajectory that lines up with those gaps, moving through a patch of daytime sky, slipping along the sun's blinding edge, or cutting across the heavens when no instrument is awake and watching. Most objects that pass through these regions are small, harmless stones. Many burn up as drifting shadows in the atmosphere, leaving only brief streaks and memories. Others sail on through, faint and unrecorded, destined to circle the sun again and again. They are not enemies. They are simply part of the timeless clutter of a busy solar system. But the pattern they reveal is important. It tells us that our greatest vulnerability may not be a single comet or asteroid at all. Instead, it is the simple fact that we are limited. We have only so many eyes, so many hours, so many instruments. Our attention is a narrow beam in a vast, dark hall. Wherever it does not shine, questions remain. In control rooms and observatories, scientists work to tighten this net. New sky surveys are planned. Space telescopes are designed to look in infrared, where heat from hidden rocks glows against the cold. Orbits are chosen that let them stare close to the sun without damage. Each new tool closes part of a gap and strengthens the walls of the fortress. Yet even as these plans unfold, the Earth keeps turning, and the sky keeps shifting. Clouds roll in, storms pass. A telescope that might have watched a crucial region is shut down for maintenance. Another loses power for a few hours. Somewhere out there, a tiny piece of rock traces its own path, indifferent to our schedules. Whether we see it or not depends on timing as much as technology. If you step outside on a clear night and look up, you cannot see these blind spots with your eyes. The stars appear steady. The constellations feel timeless. But somewhere between their familiar patterns, in regions no one is watching at that particular moment, uncounted fragments glide through the darkness, silent and unobserved. Now and then, one is discovered later, its orbit traced backward in time. Astronomers find that it passed closer than anyone knew, days or weeks before. It leaves no crater, no shock wave, only a faint data trail like a ghostly memory on a screen. In those moments, there is a quiet mix of relief and awe. Relief that nothing happened and awe at how easily it might have. As the Earth continues its endless rotation, the blind spots glide with it, shifting with the seasons, sliding over continents, folding into the rhythm of dawn and dusk. They are always there, invisible to most, shaping what we know and what we never even realize we missed. And somewhere in those silent corridors, between the soft glow of day and the deep hush of night, the unanswered question lingers like a distant echo. What stories have already passed us by, moving through our sky without a trace, leaving only a silence that we were too distracted to hear? It begins with silence, just another calm morning above a sleeping city. Then a flash brighter than the sun cuts through the clouds. Windows shatter. Shadows ripple across the snow. For a few seconds, the sky itself seems to breathe fire. That was Chelyabinsk, 2013, one of the most startling reminders that space does not need to send giants to touch us. Sometimes even a small rock, no wider than a house, can arrive unannounced and rewrite the quiet. The narrator's voice glides softly over the memory. A meteor entered the atmosphere at nearly 70,000 kilometers per hour, glowing into a streak of incandescent plasma. People saw it as a sunrise at the wrong time. Dash cameras caught its brilliance, its long white tail slicing the blue, before the air exploded into a rolling shockwave. The blast wave circled the planet twice. Hundreds were injured, not from cosmic fire but from broken glass raining down after the roar. And yet, this visitor had given no warning. No telescope had seen it coming. That is the unsettling calm at the heart of this story. The event was not an apocalypse. It was a whisper. A reminder that between the comforting patterns of stars lies a restless flow of hidden travelers, asteroids, meteoroids, and cosmic fragments following invisible trajectories through the cradle of our orbit. They are the harbingers we almost always miss. The chapter drifts back further, to the Tunguska morning of 1908. In the remote Siberian forest, the dawn came early, lit by something brighter than day. Witnesses described the horizon burning. Others heard thunder from 1,000 kilometers away. When explorers reached the site, they found 80 million trees flattened in a radial pattern, pointing outward from a single point. No crater. No rock. Just scorched silence. It was likely an asteroid or comet fragment exploding midair, releasing energy equal to a massive nuclear blast, long before such weapons existed. Tunguska was forgotten by most of the world until decades later, when science caught up with curiosity. Satellites and telescopes revealed that small bodies constantly cross Earth's path, unseen until their last few hours. Our planet lives inside a slow-motion storm of stone and ice. Most of the time, the storm passes quietly. But sometimes, it reaches down and touches us. Imagine watching the atmosphere from space. You would see brief, silent flares every few seconds, meteors vaporizing before they ever reach the ground. A steady hum of impacts, like distant raindrops on the planet's invisible roof. The Earth's atmosphere shields us from nearly all of them, turning danger into beauty, shooting stars traced in soft arcs, the color of forgotten sunsets. But every so often, one arrives too large, too fast, or too shallow to burn away completely. Then the gentle veil breaks. The narrator's tone softens further, almost like a bedtime whisper. Think of how small Earth is, it says, a single bead of life moving through a stream of ancient debris. The same cosmic material that once seeded oceans with minerals and water now occasionally returns as a threat. The same solar wind that sculpts a comet's tail also nudges countless invisible fragments along unstable trajectories, setting them on paths that cross ours. Scientists use telescopes, radar, and spectrographs to listen for these visitors. They search for faint streaks against the starlight, for the hidden anomalies that hint at something approaching. But even with all our instruments, some meteors slip through, their orbits tilted, their approach masked by sunlight or cloud. Many arrive from the direction of the sun, hidden within its blinding glare. We do not see them until they are already upon us. Each event becomes a quiet lesson written in flame. The Chelyabinsk meteor taught researchers how fragile urban glass can be under atmospheric shock. The Tunguska explosion taught us that an airburst could level forests without ever touching the ground. And both taught humility. We still do not know how many others have come and gone unnoticed, disintegrating in high air, their bright ghosts unrecorded except by satellites and faint seismic murmurs. The narrative glides between science and wonder, showing how quickly a cosmic traveler turns from harmless to historic. A small asteroid about 20 meters wide can become a fireball brighter than 10 suns in less than 3 seconds. Its speed compresses the air until the air itself becomes incandescent. The sound follows after, delayed, as though the Earth takes a moment to understand what just happened. For every Chelyabinsk we record, there may be dozens that pass unseen over oceans or deserts, leaving no witnesses, no recordings, just momentary blips in infrared sensors. We call them bolides, a word that sounds almost gentle, though their arrival is anything but. Still, the tone remains calm. These are not monsters but reminders, harbingers. The voice of the documentary grows softer, guiding the listener back into stillness. It speaks of how astronomers have begun cataloging these small bodies, mapping the near-Earth neighborhood like a patient cartographer tracing invisible rivers of stone. With every new discovery, the picture becomes more complete and more sobering. 3I/Atlas, the interstellar visitor that once seemed so mysterious, fades in importance beside the quiet swarm of smaller neighbors circling with us. The real danger may not come from beyond the stars, but from what already shares our orbit. In this calm space between fear and fascination, the script lingers. The air is filled with the faint hiss of cosmic dust. A meteor dissolves over the Pacific, unseen. Another streaks above the Sahara, leaving no sound but the soft shimmer of ionized air. Earth spins through its endless path, unaware of the fragments brushing past like memories in the dark. And then, in a single breath, the tone narrows to a question, not shouted but spoken gently into the quiet. What else is drifting beside us right now, just beyond the edge of awareness? The sound fades. The sky remains. Somewhere out there, a small stone moves silently along its trajectory, neither seen nor heard, yet part of the same timeless dance that once burned above Tunguska and Chelyabinsk. And in the drifting quiet that follows, one could almost sense that another secret is waiting, still hidden in the glow of tomorrow's dawn. Under the velvet hush of space, the narrator's voice drifts like a low tide, steady, slow, and certain. Around Earth, unseen and uncounted, thousands of rocky fragments wander through the dark. Each one moves on its own path, a relic of creation, a stone with a memory older than our planet itself. Astronomers call them near-Earth objects, asteroids and comets whose orbits cross our own like faint brush strokes across the night. Yet to the human eye, they are invisible, silent companions in the endless river of the sky. Imagine a single beam of sunlight falling through a window. You can see specks of dust floating, spinning lazily, each one moving to invisible currents of air. The narrator likens this to our solar system, a bright star surrounded by drifting motes. The sun's light reveals them only for a heartbeat before they vanish again into the dark. The planets, vast as they are only the largest pebbles in a flowing stream of cosmic debris. Between them, millions of smaller travelers glide quietly, bound by gravity, warmed by sunlight, cooled by shadow. In calm tones, the voice explains that these fragments are not random. They belong to families, asteroid clans born from ancient collisions. When two bodies met long ago, they shattered, sending pieces into slightly different orbits. Over millions of years, those fragments drifted apart, forming swarms that still circle the sun today. Some are stable, dancing between Mars and Jupiter in the wide asteroid belt. Others wander closer, pulled gently by Jupiter's vast gravity or nudged inward by the solar wind. Slowly, almost imperceptibly, their paths bend toward Earth's neighborhood. The narrator describes this motion as a cosmic migration, a slow and graceful shuffle of stones through time. Resonances, mathematical harmonies between orbits, shape their journeys. When an asteroid's path resonates with a planet's, gravity pushes it like a rhythm, pulling it slightly forward or back each time it passes. The effect is delicate yet powerful, guiding a rock millions of miles through space without a sound. In the quiet of night, telescopes catch glimpses of these wanderers, dots of light moving against the fixed stars, each with its own story written in motion. Listeners are invited to picture the Earth as a small boat adrift in this endless current. Around it, unseen, are billions of tiny bodies, ice, metal, and stone, some smaller than a pebble, others the size of cities. The narrator's tone remains soft, never alarmed. The swarm is not an enemy, it is a reminder of how alive the solar system truly is. Every meteor that streaks across the sky is one of these visitors, a brief handshake between Earth and the swarm. The air burns them to light, turning danger into beauty for a passing moment. Yet beneath the calm lies a truth. Some are larger, silent enough to escape our gaze. Scientists call them potentially hazardous asteroids, or PHAs. These are the travelers whose orbits intersect Earth's closely enough to draw attention, even if the chance of collision is small. The narrator explains how astronomers watch them. mapping their orbits, measuring their brightness, calculating where they'll be decades or centuries ahead. It's a quiet, patient vigilance. Most will never come close, but the fact that a few might is enough to keep telescopes awake through countless nights. The story turns toward the subtle forces that shape these orbits. Gravity is the composer, but sunlight adds the melody. When light strikes one side of an asteroid, the rock warms slightly, then re-radiates that heat as it spins. Over years, this faint push, called the Yarkovsky effect, can alter a trajectory by thousands of miles. It is a whisper of physics at work, invisible but relentless. Even the smallest stones feel it, shifting course like leaves on a breeze that never stops. In this soft explanation, science becomes music. The narrator compares the movement to a dance. Each asteroid steps to a rhythm set by forces older than the planets themselves. The solar wind hums through space, a constant exhalation from the sun. It wraps around the swarm, brushing over surfaces, pushing dust and ice into new patterns. Sometimes it reveals a hidden comet, a faint shimmer suddenly trailing a tail. Other times, it darkens one face of a rock until it becomes nearly invisible. The solar wind both hides and reveals, as if the universe is gently rearranging its pieces while no one watches. Through gentle pacing, the listener feels the scale, immense yet serene. The narrator reminds us that space is not empty, it is a living sea of motion. Every piece of dust, every rock, every faint glimmer is part of the same shared ecosystem. Earth does not sit at the center. It drifts among neighbors it will never truly meet. The voice softens. We live within a slow storm, not of wind or rain, but of ancient stones that remember the birth of everything we know. The scene shifts to human hands guiding telescopes. The story of the swarm becomes a story of watchers. Astronomers mapping tiny points of light, running calculations, checking the same data for years to see if a dot has moved. Some discoveries are made accidentally. An amateur spots a faint streak across a digital image, or a student notices a pattern others overlooked. Behind every discovery is patience, repetition, and wonder. The narration lingers on this idea, that most of the universe reveals itself not through drama, but through stillness and attention. There's a pause, a sense of floating. The narrator's tone lowers, almost a whisper. Every year a few more are found. But there are countless others, hidden in the brightness of the sun, behind the glare of daylight, or too small for our instruments to see. The silence that follows feels like a held breath. We share this orbit with millions of quiet travelers, and most will pass us by, unknown, unseen. Yet each one carries with it a history. The formation of planets, the collisions that built worlds, the dust that became oceans and mountains. Then, almost imperceptibly, the tension melts back into calm. The voice reminds us that awareness is its own kind of safety. The more we understand the sky, the more its silence becomes comforting rather than ominous. What once felt like a threat becomes part of the great pattern. Evidence that we are not isolated but surrounded by memory and motion. The swarm around us is not a warning. It's a song about connection, gravity, and time. As the chapter closes, the language turns softer still. The stars above are described as slow-burning lanterns, casting a gentle glow over the unseen drift of rocks between them. Earth spins silently through that glow, wrapped in a veil of protection and chance. The narrator leaves the listener with a thought that feels both fragile and eternal. If we share this cosmic river with so many quiet neighbors, how many more drift unseen, passing within reach, never speaking but always there, just beyond the light? At first light, the horizon glows with a slow, liquid gold. The stars retreat, one by one, fading behind a soft veil of brightness. The world wakes to daylight, but in doing so, something else vanishes, our vision of the universe. Every morning, as sunlight floods the sky, our instruments go blind in one direction. In that radiant curtain near the sun's glare, mysteries drift unseen. Comets, asteroids, and even unknown travelers could be moving across that blinding backdrop, invisible to the eyes that watch the rest of the heavens so carefully. The narrator's voice is soft, steady. Imagine, it says, a comet the size of a mountain gliding toward us from the direction of dawn. It carries the frozen memory of another age, trailing a whisper of ice and dust. But to every telescope on Earth, it does not exist, not yet. The sun hides it perfectly, as if tucking a secret behind its own brilliance. Astronomers call it the daylight problem, a blind wedge stretching tens of degrees across the sky where ground-based telescopes cannot see. No matter how powerful the lens, the sun's radiance overwhelms it. The solar wind, that invisible river of charged particles, scatters light and dust, turning this zone into a shimmering fog. For centuries, This region has been where some of the universe's most unannounced visitors arrive. The Tunguska impactor of 1908, they say, came from a direction close to the Sun. So did several near-Earth asteroids that passed quietly within cosmic reach, unseen until they had already gone. Now, as technology advances, humanity is learning to peer into this forbidden region. Specialized space telescopes float beyond the blur of Earth's atmosphere, watching the sky in wavelengths that our eyes cannot perceive. The narrator describes one of them. NASA's NEOWISE, orbiting high above, its infrared sensors listening not for visible light but for warmth. Everything in space gives off heat, the voice continues. Even cold rock, even ice drifting in shadow. To an infrared eye, a hidden asteroid becomes a faint ember moving through darkness. In this calm explanation, numbers become whispers, temperatures of frozen carbon dioxide, subtle differences in infrared color, the faint thermal trail of an object turning slowly in orbit. The audience is reminded that visibility is not about brightness alone, but contrast. Against the golden glare of the sun, a small asteroid can vanish completely. Yet to an infrared spectrograph, it glows softly like a coal behind glass. The story flows toward another telescope, the Solar and Heliospheric Observatory, or SOHO. Though designed to study the sun, it has found thousands of comets, streaking across its field of view like glowing messengers skimming too close to fire. These are sungrazers, comets whose orbits carry them perilously near the sun's surface, where their ice vaporizes into luminous haze. Many are destroyed completely, leaving only a brief signature in data. The narrator's tone grows reflective. They come silently from the deep, burn in daylight, and vanish before night returns. Their entire existence, unknown, unseen, plays out behind the glare. The calm rhythm continues, balancing science and wonder. We hear how astronomers at observatories around the world schedule their scans carefully, avoiding the sun's position. They track objects at night, extrapolating orbits with mathematics and memory, but there is always a window of uncertainty, a space they cannot watch. Somewhere in that glowing wedge, a drifting shadow could be adjusting its path, invisible but real. To make sense of this, the narrator compares the sun's glare to a blind spot in human vision, a place the brain fills in, pretending it can see what it cannot. The sky, the voice says, does the same for us. Between the regions of midnight and noon, there are places where we imagine emptiness, but we simply haven't looked long enough. As the narration softens, sound design fills in with gentle imagery, the hum of solar wind, faint static like starlight filtered through air, the whisper of instruments moving in orbit. The story describes new projects, missions planned to station telescopes far from Earth, like NEO Surveyor, set to observe from a dark vantage where the sun's light is not blinding. It will see asteroids that sneak inward from the direction of day, the ones that could surprise us most. The idea isn't fear, it's awareness. The calm tone reassures the listener that humanity's vigilance grows stronger. But there's poetry too, the recognition that in the brightness we love, the sunrise, the golden warmth of noon, there lies a hidden frontier. Light, after all, is both revealer and concealer. Our star, the narrator says softly, keeps us alive and blinds us at the same time. It hides what approaches from its direction, protecting and deceiving in one motion. A gentle pause follows. The music hushes, replaced by the slow pulse of ambient tones. Some astronomers, the voice adds, have learned to listen differently. When they cannot see, they search for gravitational traces, tiny wobbles in orbits, changes in the paths of known objects that suggest something unseen has passed by. The explanation is simple but elegant. Physics as detective work, inference as sight. As twilight returns in the story, colors fade from gold to blue, and stars reappear above the horizon. The narrator lingers on this image, the reawakening of the night sky after hours of blindness. One by one, the telescopes resume their watch, sweeping the dark with quiet persistence. The unseen region behind the sun's light drifts westward, changing faces but never disappearing. It remains a moving mystery, always ahead of the dawn. The final passage grows reflective, almost whispered. Perhaps, the narrator says, there are visitors hidden even now in that radiant curtain, ancient travelers passing unnoticed through the golden light, unseen messengers bound for distant orbits. We will not know until the sun turns away, until the light fades enough to reveal what was always there. A hush lingers for several seconds, filled with soft music and faint static, like the murmur of the solar wind itself. And then the voice closes quietly, warm and deliberate. Every morning the light returns and with it our blindness. Yet in that blindness the universe hides its secrets. Somewhere in the brightness of dawn, something moves, a drifting shadow, a silent ember, waiting for night to fall again. The silence deepens, yet hidden in that silence is something waiting to be understood. High above the thin blue veil of Earth, a silent orchestra performs without rest. Tiny flashes of sunlight ripple across a dark backdrop as fragments of metal, paint, and glass drift endlessly in orbit. To the untrained eye, it's emptiness. But to telescopes and radar arrays, it's a traffic jam, a cosmic one. The narrator's voice moves softly, steady as orbital rhythm, painting a picture of Earth surrounded by its own creation, a halo of machinery, memories, and mistakes. For every gleaming satellite that beams signals down to our phones, there are dozens of quiet ghosts beside it. Spent rocket stages, broken solar panels, forgotten missions from decades ago. They drift together in graceful but dangerous choreography. Some circle peacefully, others travel faster than bullets, capable of turning a working satellite into glittering debris in an instant. The space above us, once clean and vast, now glimmers with what scientists call orbital debris. The camera of imagination pans slowly outward. At about 500 miles up, satellites trace ribbons of light, communications, weather, GPS. Higher still, at 22,000 miles, another ring shimmers, geostationary orbit, where old broadcasting platforms still hang, long past their service life. Together, these layers form a metallic shell around our planet, a quiet fortress of human ambition and unintended consequence. The narrator's tone stays calm, patient, and clear. The story of this cluttered sky begins in the Cold War, when rockets rose with fire and smoke to carry the first machines into space. Launch left fragments, bolts, insulation, even gloves lost by astronauts, trapped by Earth's gravity. Every collision, every explosion added more. In the language of orbital mechanics, these fragments form chains of motion that multiply themselves. Scientists gave this phenomenon a name, the Kessler syndrome, a runaway cascade where one collision breeds another, spreading fragments like a cosmic infection. Listeners are guided gently through this idea. Imagine a single satellite breaking apart. Its pieces scatter, striking others, turning hundreds into thousands. Over years, the fragments drift apart, forming new bands of risk. Each one circles Earth every 90 minutes, a deadly ballet beneath the whisper of stars. In soft tones, the narrator explains that space isn't an infinite void around our world. It's a fragile neighborhood that humans are slowly crowding. The perspective widens again. Beyond human debris, natural visitors still come. Small meteors from forgotten comets, fragments of ancient asteroids glowing briefly as they burn in the upper atmosphere. The narrator contrasts these timeless travelers with human-made debris, the first born of nature, the second of invention. Both streak across the same cradle of silence, yet only one is our doing. Inside observatories, telescopes try to trace this tangled dance. They search for real cosmic anomalies, asteroids, comets, the faint signatures of unknown travelers. But the clutter we've created often masks the signals. A piece of metal catches light and looks for a heartbeat, like a moving star. Radar echoes mix artificial fragments with genuine cosmic bodies. The narrator pauses, allowing listeners to feel the irony. In trying to study the universe, we've filled the sky with noise that drowns out its whisper. The voice softens, inviting reflection. Humanity built these machines for connection, for navigation, communication, weather, and exploration. Each object once carried hope, purpose, and human touch. But in orbit, there's no decay, no wind, no rain. What goes up stays, circling for decades or centuries. The layer grows denser, and with it comes the question: what happens when the sky itself becomes too full to see through? Gentle background imagery forms. A satellite tumbling end over end, its solar panels flashing sunlight like a heartbeat. A paint fleck spinning silently past, smaller than a grain of sand yet traveling fast enough to pierce metal. The narrator explains that even tiny fragments, invisible to telescopes, carry immense energy. One strike, and a spacecraft could vanish into fragments indistinguishable from dust. The danger isn't cinematic, it's statistical. Each orbit is a gamble in a crowded theater with no sound. Then, in calm wonder, the tone shifts. Despite the clutter, Earth's watchers continue their work. International networks track every known object larger than a softball. They calculate trajectories, map risks, and predict possible collisions. In the quiet halls of mission control, monitors glow with dots and numbers, an invisible storm rendered into coordinates. It's a form of stewardship, a promise to preserve what we once claimed was infinite. Listeners are reminded of perspective. From 1,000 miles away, Earth still shines in blues and whites, beautiful beyond measure. The debris halo is invisible to the naked eye, a thin mist against the vast black. Yet, symbolically, it's enormous, a mirror of our behavior, a story of creation without cleanup. The narrator invites a moment of empathy. Even the most advanced species can fill its own sky before it truly understands how fragile it is. There's a brief note of optimism. Engineers dream of solutions. Robotic sweepers that capture debris, satellites equipped with nets or magnets, concepts for controlled re-entry. Some ideas already fly as prototypes. Tiny machines testing whether humanity can erase its cosmic footprints. These stories unfold gently, not as promises but as possibilities, drifting like hope through the darkness. The mood slows as the narrator's voice lowers, merging science with lullaby. Around Earth, natural meteors continue to fall, soft arcs of light dissolving in the upper air. Artificial debris glints back, colder, more rigid, yet equally transient in the scale of time. The universe neither blames nor forgives, it simply waits. As the music fades to quiet hum, the listener is left with a haunting image. Earth, wrapped in a shimmering belt of its own making, turning beneath the stars. Somewhere beyond that haze, true cosmic messengers still travel. Ancient comets, drifting anomalies, signals from deep space. But through this busy ring of human echoes, their voices grow faint. And so, the narrator wonders aloud, barely above a whisper. In this cluttered fortress we've built, filled with memory and motion, can we still hear the faint cosmic whisper from beyond? The night begins not with darkness, but with quiet. Inside the observatory, machines hum softly while a red light glows faintly against walls lined with instruments. Outside, the wind slips through the trees like a slow breath, and above it all, beyond glass and steel, the stars shimmer, scattered across the sky like letters waiting to be read. Each pinprick of light carries a story billions of years old, and tonight humanity listens. Spectrographs, delicate and patient, open their eyes to the universe. These instruments do not see stars as we do. They break light apart, spreading it into ribbons of color, each hue a clue. Within those shimmering bands lie fingerprints of gases and dust, of motion and heat, of composition and mystery. Hydrogen glows soft red, sodium burns in gold, and oxygen shimmers in faint teal. It's as if the stars have written their own diaries in light, and we are slowly learning to translate them. Imagine sitting beneath the dome as the telescope turns. A comet drifts across the black, its tail a thin, luminous haze trailing behind like a whisper of smoke. Through the spectrograph, that ghostly trail is not just beauty, it's chemistry. Water vapor, carbon dioxide, fragments of ammonia and methane, all revealed by the faint signatures they leave in the light. From this data, scientists can tell the comet's age, its birthplace, and sometimes even its secrets, frozen clues from the beginning of the solar system. The voice of the narrator remains calm, like a late-night storyteller. Every photon carries a memory, it says. Each one traveled across an ocean of space to reach this single mirror, this single moment. It's easy to forget how far that journey truly is. Light that began before the first humans painted caves, before mountains rose, before the oceans took shape. And now, in this quiet dome, that same ancient light flickers across a digital screen, humming faintly in human code. Yet sometimes, those lines in the spectrum don't match what we expect. There are anomalies, tiny distortions, sudden gaps, or unfamiliar colors that don't belong to any known element. Scientists pause, scroll back, check calibration, rerun data. Still, the anomaly stays. Was it dust between stars? A signal from an instrument? Or something stranger? A signature of a material we've never seen from a place we've never imagined? These are not errors, they are mysteries. A soft whisper from somewhere else, hinting that the cosmos might still have words we don't yet know how to pronounce. The narrator's tone deepens, describing a discovery in 2017. An unexplained radio burst, lasting just milliseconds, from a galaxy billions of light-years away. It repeats occasionally, faint and stubborn, each pulse carrying the same structure, as if something out there is knocking softly, again and again, waiting for someone to notice. Through it all, the spectrographs keep watching. They listen not with ears, but with patience. Some are mounted on mountain peaks where air thins and cold sharpens the senses. Others float in orbit, beyond the distortion of the atmosphere. Together they collect the sky's secrets, building a silent archive of cosmic whispers. Somewhere in those petabytes of light, maybe one line, one pattern, will someday reveal something profound. But what if the bigger problem isn't what we fail to detect, but what we fail to interpret? We're fluent in the language of matter and energy, but what about meaning? We can measure a star's orbit, its surface temperature, its mass down to decimals. Yet the universe speaks in poetry, not precision. A redshift tells us something is moving away, but not why. A fading line tells us an element cooled, but not what story it was part of. Maybe beneath the physics there is another layer, a language of rhythm, pattern, and timing that we have not yet learned to translate. The narrator's voice softens further. Imagine if every shimmer of starlight was more than just light. Imagine if it was a message. It's not a claim, just a thought, offered like a stone dropped gently into a still pond. The ripples of that thought move outward, touching ancient questions about intelligence, coincidence, and wonder. In the gentle silence, listeners are left to picture scientists alone at midnight, eyes fixed on the data, wondering if they've just glimpsed something alive in the numbers. The chapter drifts now toward the emotional, the human side of science. The observer yawns, stretches stiff hands, and writes down readings that might someday change what we know about existence. They work not for fame, but for the quiet satisfaction of decoding the unknown. The wind hums faintly outside. A shooting star crosses the sky, invisible to instruments but bright enough to remind us why curiosity endures. Each night, these watchers collect more of the universe's sentences. Sometimes the meaning leaps out, a new exoplanet, a comet's chemistry, a distant supernova. Sometimes it's only noise, the hum of creation too complex to parse. But occasionally, hidden in the static, a pattern appears, too consistent to dismiss, too subtle to explain. Those are the moments that keep them awake. The moments that make them believe that something, somewhere, might be speaking back. The idea lingers, we might not just be missing objects, but meanings. A drifting shadow between stars may be a rock, or it may be a messenger. A spectral line may be a signature or a question. We measure, we compare, we publish, but still, some things don't fit neatly into columns and charts. Maybe they're not supposed to. The dome closes for the night. Instruments power down, the red light dims, and the stars fade into dawn's soft veil. Yet even as the world wakes, the data remains, endless rows of numbers, frozen echoes of a conversation older than time. Someone, someday, will open them again and listen. And somewhere in those shimmering bands of color, scattered across a screen like the brush strokes of the sky itself, may lie the faint reply of a universe that has been speaking all along. The silence deepens, yet hidden within that silence is something waiting, something that wants to be understood. He drifts through the darkness like a lost ember from another fire. No trail, no returning path, just motion through the deep silence between stars. Astronomers first gave him a name, Oumuamua, a Hawaiian word meaning scout or messenger from afar. He came from nowhere, crossed the solar system with quiet precision, and was gone before we could truly understand him. Months later, another stranger appeared, 3I/Atlas, its faint green haze barely captured by telescopes before it too began to fade. These are not isolated visitors, the narrator explains softly. They are clues, tiny signatures of a greater truth. For every one we glimpse, countless others drift unseen through the cradle of darkness. Oumuamua's path was unlike anything scientists had recorded. It entered the solar system on a hyperbolic trajectory, its orbit open, not bound by the sun's gravity. Unlike comets or asteroids that circle back after decades, Oumuamua would never return. It accelerated slightly as it passed the sun, as though nudged by something invisible, perhaps outgassing, or perhaps an anomaly beyond our understanding. In observatories from Hawaii to Spain, telescopes traced its faint light, translating starlight into data through spectrographs that whispered secrets in colors. Some expected dust, none was seen. Others searched for a coma, a luminous haze, but the void remained clean. It was a body that broke our categories, leaving behind only questions and a fading line through starlight. 3I/Atlas followed a few years later, a smaller messenger wrapped in ice and vapor, glowing like a green lantern in the cosmic sea. It too traveled on a hyperbolic path, another drifter from beyond the sun's domain. These interstellar objects are ancient travelers, fragments of shattered worlds, icy debris from star-forming regions long forgotten. Each one carries a story. Older than Earth itself, a particle of history released from some distant system, now sliding briefly through ours before vanishing again into the galaxy's endless night. The narrator pauses, allowing the listener to imagine these wanderers suspended in a vast, invisible current, the interstellar medium. Between the glowing nebulae and the cold dust clouds, fragments drift for millions, perhaps billions of years. Their surfaces darken with cosmic radiation, their cores remain frozen and silent, their trajectories nudged by the slow pull of distant suns. When one finally crosses our path, it is like finding a single grain of sand from another beach carried by a storm we cannot see. Scientists have begun to estimate how many might exist, tens of trillions of such objects roaming the galaxy, silent and unbound. Most will never come close enough for our telescopes to detect. A few might wander near the solar wind and briefly flare as sunlight warms their skin. They are, in a way, the messengers of the galaxy's memory. Some may have once orbited other stars, their parent systems long gone, their planets broken by time. Some may carry the chemical fingerprints of organic molecules, the same fragile patterns that seeded life here. If these travelers could speak, what languages of dust and ice would they use? What forgotten suns would they remember? In laboratories and observatories, scientists analyze the faint traces left behind. Spectral lines, colors of reflected starlight, and subtle curves and trajectories, all clues in a cosmic puzzle. The data from Oumuamua showed something peculiar. It reflected light unevenly as if shaped like a flattened disk or a shard of mirror. No one knows for sure. Some suggested a fragment of rock blasted from another planet. Others whispered of technology, though evidence never confirmed it. Still, the idea lingered, the possibility that some travelers might not be natural. The thought was not shouted but held softly like a fragile flame. What if the universe had once built something that could drift forever, long after its creators were gone? But the mystery is larger than speculation. The greater truth, as the narrator explains in a slow, calming rhythm, is that our detection of Oumuamua and 3I/Atlas is proof of our blindness. We saw them only because they happened to pass through our narrow field of view. The rest, the countless unknown travelers, remain invisible, slipping silently between stars, past our sensors, through the gaps in our cosmic watch. Their presence reminds us how incomplete our understanding still is. We have mapped planets, catalogued thousands of exoplanets, measured pulsars and nebulae, but in the dark between ancient fragments move unseen. Imagine the quiet space between galaxies. There, the narrator says, the density of matter thins to almost nothing. Yet even there, particles drift. Dust from supernovae, shards of forgotten systems, cold wanderers that never belonged to any sun. They are the galaxy's lost children, moving endlessly through the void. A single object might take 10 million years to cross the distance between two stars. During that journey, it will see no light, feel no warmth, and carry within it the frozen chemistry of another world. It is not life, but it is a witness to where life might have been. The human mind struggles to hold such scales, time measured in eons, distance in trillions of miles. Yet, under the soft hum of the narrator's voice, these vast measures begin to feel intimate. Because even as we sleep beneath our atmosphere, the Earth itself is moving, its orbit a slow circle around the sun, and the sun's own path an even slower orbit around the center of the Milky Way. We, too, are travelers between stars, riding our fragile world through a galaxy filled with unseen motion. Every meteor streaking across the sky, every whisper of a comet's tail, is a reminder that the space between stars is not empty, only quiet. And still, the question lingers, how many have passed us by unnoticed? Could one have drifted through the outer solar system centuries ago, its presence lost to the silence of time? What stories might it have carried? Molecules of water, carbon chains, the dust of ancient suns. The thought is both humbling and serene. We are surrounded by messages written in motion, yet we only see the few that glint in our direction. In this calm realization, the narrator slows their voice. The galaxy is not a static place. It breathes, shifts, and exchanges matter across unimaginable distances. Each interstellar object, Oumuamua, 3I/Atlas, or the ones we'll never know, reminds us that the boundaries of our solar system are porous, that the space beyond is not a wall but a sea. Somewhere out there, another shard is already on its way toward us, unseen for now, following a path written by chance and gravity. It may pass within decades or centuries, or it may already be here. Hidden in the sunlight, a faint drift against the stars. The music fades into quiet. The listener is left with a sense of awe, not fear. The cosmos is not empty, it is full of wanderers. We are simply learning to notice them one flicker at a time. And in the drifting quiet of the night, one can almost sense that something, another messenger from afar, is already approaching, gliding through the cradle of silence toward the waiting light of our sun. In the quiet cradle of night, the narrator's voice begins like a soft ripple across time, calm, reflective, almost whispering. Imagine standing on an open plain beneath a pale moon. The air is still. The land around you seems timeless. Yet beneath that stillness lies a record older than any story, etched not in ink but in stone. Every crater, every circular depression you might see from orbit or a desert ridge, is a memory of something that once came blazing through the sky. The Earth, the Moon, and Mars all bear these scars. They are like pages of a cosmic diary, silent witnesses to the universe's restless energy. On Earth, vegetation and oceans have softened most of them. But on the Moon, where no wind blows and no rain falls, the surface remains a gallery of impact history. Each crater glows faintly under the sun's angle, its rim catching light like the edge of an old wound. These are echoes of collisions that once shook the silence of space. Long ago, before humans watched the stars, the solar system was a crowded stage. Debris swirled in endless orbits. Asteroids, comets, and fragments left from the birth of planets. Gravity pulled them into intersecting paths. Some passed quietly through, others struck worlds with unimaginable force. Each impact reshaped its target, melting stone, boiling oceans, and tilting destinies. The narrator explains how scientists, through telescopes and spectrographs, study these scars not only to understand destruction but to read the hidden poetry of creation. One such moment, the great impact that ended the age of dinosaurs, still speaks across time. About 66 million years ago, a rock the size of a mountain entered Earth's atmosphere at over 20 kilometers per second. For a few seconds, it became brighter than the sun. The shockwave erased forests, ignited global fires, and sent vaporized rock into the stratosphere. Dust drifted like a dark veil over the sky, cutting off sunlight for years. In that cold, dim world, much of life faded. Yet from that silence, new forms of life began to rise. The narrator's tone softens, painting that ancient night in slow detail. A soft glow fading to darkness, the oceans cooling, the winds slowing, and eventually, a fragile dawn returning. This balance of ending and renewal, of death and creation, seems written into the pattern of the universe itself. The impact was both catastrophe and reset, proof that even destruction can carry the seeds of change. Scientists trace similar marks across other worlds. On Mars, craters hold frozen rivers and deltas, evidence that impacts once melted ice and created brief, warm periods when water flowed freely. The Moon's vast basins tell of a time called the Late Heavy Bombardment, when the inner planets endured a rain of stone lasting hundreds of millions of years. The narrator describes it like a storm without sound, a cosmic rain that carved the early face of our solar system. Through orbital mapping and dating techniques, researchers can now read this record like music written across epochs. Isotopes in ancient rocks reveal when impacts occurred. Spherules, tiny glass beads scattered in sediments, mark moments when the air itself turned liquid with heat. Each finding adds a note to the symphony of Earth's history, showing how life and environment evolved together in response to these cosmic visitors. Even now, traces of those events linger in the quiet landscapes we walk upon. Beneath green fields, mountain ranges, and ocean floors lie the outlines of forgotten craters. Some are vast, hundreds of miles across, now hidden under forests or ice. The Chicxulub crater, buried beneath the Yucatan Peninsula, still hums faintly with the story of that fateful day. Seismic instruments record the density of its layers. Sonar reveals its perfect, circular geometry. To scientists, it is less a scar and more a heartbeat, proof that our planet remembers. The narrator's voice slows further, almost as if inviting the listener to breathe with the planet. These impacts, though violent, have guided evolution in quiet ways. They brought minerals from the depths, mixed atmospheres, and even delivered water and organic molecules, the building blocks of life, from beyond Earth. Each collision was a test of endurance, a lesson in cosmic resilience. And yet, destiny and chance walk side by side. Had that asteroid been smaller or entered at a different angle, dinosaurs might still rule, and mammals might never have risen. In that delicate balance lies the reminder of how fragile our story is. Every epoch, every creature, exists because of the countless cosmic dice rolls that came before. The imagery turns introspective now. Imagine lying beneath the night sky, aware that each star you see has likely witnessed impacts of its own, worlds scarred, reborn, reshaped. Some of those impacts may have sparked new life elsewhere. Some may have ended civilizations we'll never know. Across galaxies, the same process repeats. Creation through collision, order from chaos. There's a calm inevitability in this pattern. The universe builds, destroys, and rebuilds without pause. It is both artist and storm. The chapter weaves this truth like a lullaby, inviting the listener to feel small yet connected, to understand that our very existence is part of this rhythm. Even our fears of future impacts are, in a way, echoes of that memory written in our collective past. As the soundscape fades, Soft wind, faint ocean tide, the quiet hum of distant thunder. The voice returns, low and reflective. If our past was changed by stones from the dark, how might unseen objects still shape our future? The thought lingers like starlight reflected in deep water. The silence deepens, carrying a faint shimmer of awe. Somewhere in that quiet vastness, fragments continue their slow orbits, each one a messenger, waiting for its moment to speak again. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. High above the surface of the earth, a quiet battle unfolds each day, one that few ever see and fewer still understand. Invisible currents ripple through the upper atmosphere, where drifting particles from the sun meet the thin veil of air that protects everything living below. In this calm ballet of physics and chance, the planet's defenses work ceaselessly, turning chaos into beauty. When a meteor enters Earth's orbit, it begins as a silent traveler, an ancient pebble that has drifted through millions of miles of emptiness. As it strikes the atmosphere at tens of kilometers per second, air compresses before it, heating the rock to incandescence. In an instant, that hidden stone becomes a streak of light, a soft, luminous haze across the night sky. It's a small death turned into a quiet spectacle, a reminder that our safety often appears as beauty. For every shooting star that fades gracefully into the dark, countless others never reach the ground. The air, invisible yet dense compared to space, is our first and most faithful shield. Molecules of nitrogen and oxygen act like a cosmic cushion, slowing, burning, and scattering intruders before they can harm what lies below. The friction produces light, the light produces awe, and awe gives birth to stories, tales of celestial visitors, omens, and dreams that humans have told since the first nights of fire and sky. But above this glowing barrier, another shield hums, one that cannot be seen even by the keenest eyes. Earth's magnetic field, born from molten movement deep within the planet's core, extends outward like an invisible fortress. It forms a cocoon that bends the paths of charged particles hurled by the sun, redirecting them away from the fragile layer of atmosphere and life. To the instruments aboard satellites, this magnetic field looks like curved lines, arcing around the planet in shimmering loops of force. To the human imagination, it's something softer, a guardian made of silence and motion. The solar wind never stops. Streams of charged particles flow outward from the sun like a slow, invisible tide. When they reach Earth, the magnetic field deflects most of them, guiding the particles toward the poles. There, where the defense is thin, the particles collide with molecules high in the atmosphere, creating the auroras, green and violet curtains that shimmer across the night sky. Imagine standing beneath them, the air cold, the world quiet, the sky alive with color. Each flicker is a whisper of that unseen protection, energy turned into art. What begins as danger ends as light. The magnetic field transforms chaos into calm, like a conductor shaping storm into symphony. And yet, these shields, both of air and magnetism, are not perfect. Sometimes something larger comes. Every few decades, a meteor the size of a house slips through the defenses, exploding in a bright burst of energy that rattles windows and wakes sleeping towns. Larger still, asteroids several hundred meters across carry enough momentum to scar continents. They remind us that our protection, while powerful, has its limits. Beyond the meteors, the sun itself can threaten the balance. During intense solar storms, waves of magnetic energy wash over the Earth, distorting the planet's magnetic field like ripples in a pond. These storms can light up the auroras far from the poles, painting skies in colors usually reserved for Arctic nights. But they can also overload satellites, disrupt radio waves, and even cause power grids to fail. The same invisible guardian that shields us can, under enough stress, tremble. Scientists watch this invisible battle through a network of satellites and observatories. They measure the speed of solar wind, map magnetic lines, and track the behavior of the upper atmosphere. From their data comes a kind of quiet reassurance. Earth's defenses still hold. But each reading also carries a reminder. Our safety is not guaranteed by permanence, only by balance. The planet is a living system, its shields pulsing and shifting like the breath of a sleeping giant. At times, that breath falters. Small anomalies appear, openings where radiation slips through, temporary holes in the ozone, fluctuations in the magnetosphere. They close again, but their presence lingers as warning. Even the oldest fortresses need watchmen. Astronomers, atmospheric scientists, and physicists all play the same role, guardians not of the Earth itself but of our understanding of it. In quiet laboratories and mountain observatories they listen. Spectrographs hum as they record wavelengths of light from the aurora, magnetometers trace invisible changes in the field. Each curve, each color, each faint shimmer tells a story of cosmic energy meeting earthly resistance. And as night settles, the data becomes something more, a lullaby of numbers that tells us the shield still sings. The narrator's tone softens, imagining how this unseen protection must look from space. A glowing sphere wrapped in blue haze, crowned by ribbons of green light, floating in a black ocean of silence. It is fragile and eternal all at once, a dream balanced against the void. The faint hum of the magnetic field, if one could hear it, would sound like the Earth's heartbeat. But fragility is not weakness. The air and the magnetism that defend us have done so for billions of years. They have turned away countless storms, softened the blows of comets, and held back radiation from dying stars. Humanity was born under their protection, evolved in their shadow, and built civilizations beneath their glow. Still, the story carries a quiet unease. There are forces beyond even these ancient shields, supernovae that can strip atmospheres, pulsars that beam lethal energy across space, and black holes whose very gravity reshapes time. Against such immensities, Earth's defenses are as thin as silk. Yet that silk has held so far. As the chapter draws toward stillness, the narration invites a slow breath. The listener is reminded of the miracle that air itself is our first line of defense, that magnetism, a thing we cannot touch, keeps our world safe. Above every sleeping city, meteors burn and fade into memory, auroras drift and vanish, and the Earth continues to spin beneath its unseen armor. The voice fades to a whisper, our shields hold but only for as long as the stars allow. And somewhere beyond that soft glow, in the vast quiet of the cosmos, something waits, something that even air and magnetism might not stop. The night opens with quiet stillness, a vast canvas where the stars shimmer like faint embers scattered across an infinite sea. The narrator's voice glides softly, tracing the invisible borders of our solar system and then slipping beyond, into the deep reaches where light itself struggles to travel. Here, far from the warmth of our sun, storms rage unlike anything we've ever known, storms not of wind or water but of radiation, gravity, and time. In these places, stars live intense, dramatic lives. They are born from swirling clouds of dust and gas, nebulae glowing in pinks and blues like painted dreams. They grow, burn, and eventually die, some gently fading into white dwarfs, others in violent collapse becoming black holes or neutron stars. Every ending is an explosion of creation. When a massive star's nuclear fire runs out, it falls inward and then erupts outward. A supernova, one of the most powerful events in the cosmos. The voice describes how, for a moment, one single star outshines an entire galaxy. It sends a pulse of light and energy racing across space, a whisper from one corner of eternity to another. These supernovae create the very elements we depend on, iron in our blood, calcium in our bones, gold in the jewelry we wear. Each heavy atom was once part of such a storm. The listener can almost imagine it. Dust drifting from the wreckage of a dying star, floating for eons until it settles into the forming earth. But not every burst remains beautiful. The narrator explains gently that when a star dies violently, it can release radiation powerful enough to strip atmospheres from planets thousands of light years away. A nearby supernova could bathe Earth in harmful particles, altering the upper layers of our air, breaking apart molecules that protect us from ultraviolet light. It wouldn't burn the ground, but it could quietly change the chemistry of life itself. It's a reminder that the universe, while majestic, is not always kind. Then, like a calm tide, the focus drifts to gamma-ray bursts, brief flashes of unimaginable energy, lasting seconds yet carrying more power than the sun will produce in its entire lifetime. The narrator compares them to cosmic lightning, streaking through the universe in silence. Some come from collapsing stars, others from merging neutron stars that spiral together, releasing a final cry of light before fading into darkness. Scientists track these events using satellites that watch for invisible waves of energy, their instruments catching faint flickers that might have traveled billions of years to reach us. For a moment, the script slows, inviting the listener to picture those signals as fragile messengers crossing the abyss, arriving as little more than whispers. Imagine, the voice says softly, that the light striking your eyes tonight began its journey before humans existed, before Earth had mountains or oceans. The sense of scale stretches the imagination, wrapping the mind in wonder and humility. The story now moves to calmer galaxies, described like great storm systems of stars. Some spiral in graceful arms. Others are colliding, throwing clouds of gas and dust into new formations. These collisions trigger starburst regions, places where newborn stars ignite by the thousands, each with its own orbit, its own destiny. Yet within these bright regions lurk black holes, the quiet centers of chaos. The narrator explains that supermassive black holes, millions of times heavier than our sun, sit in the hearts of galaxies. They feed on matter and radiate energy in waves that ripple through space, bending time and reshaping their surroundings. The tone remains gentle, even when describing destruction. The narrator compares these galactic storms to weather patterns, a cosmic cycle of birth and decay. Stars explode, the voice murmurs, but from their ashes come new suns, new planets, and perhaps new beginnings. This rhythm of death and renewal, chaos and calm, feels strangely familiar. It mirrors the tides of human life, where endings so often create the ground for something new. Listeners are guided next through the soft imagery of nebulae, remnants of past explosions glowing in the dark. Through the telescope's eye, they appear as brush strokes of color, drifting silently through the void. These are the graves of stars and the cradles of the next generation. A spectrograph reads their light like a memory, showing traces of hydrogen, helium, oxygen, and carbon. The narrator explains how each line on the spectrum tells a story, how the faint shimmer of a nebula is both a goodbye and a promise. Gradually, the chapter folds from vast violence into intimate reflection. The narrator wonders in a calm whisper, how small our own sun must seem amid these storms. It burns steadily, a gentle hearth in a dangerous galaxy. Around it, the solar wind flows like a protective breeze, pushing back cosmic rays and interstellar dust. Our planet, fragile and bright, drifts within this safety zone, one calm pocket in an otherwise restless sea. Yet even here the balance feels temporary. What happens, the voice muses softly, when a distant star flares brighter than expected? When a pulse of radiation moves through the galaxy like an invisible wave? The listener is reminded that cosmic time moves slowly, but its consequences are lasting. The narrator paints an image of a pulse of energy still traveling toward us, perhaps light that left its source when the first humans painted on cave walls, still making its way across the void. The focus shifts subtly toward perspective. The bigger problem, as the narrator puts it, is not danger itself but the illusion of control. The universe is immense, filled with forces beyond our reach, and yet here we are, alive, conscious, capable of looking up and asking why. This realization, though humbling, becomes oddly comforting. We survive not because the cosmos is safe, but because it allows us to exist within its wildness. A moment of stillness follows. The music beneath fades into a faint hum, like the low frequency of distant stars vibrating through the night. The voice grows softer, almost meditative. Every atom in you was forged in one of these storms. You are not apart from them. You are their continuation, the quiet echo of an ancient explosion, still glowing softly in human form. The imagery settles, galaxies turning like slow hurricanes of light, black holes pulsing unseen and far away, a gamma ray burst fading into nothing. The night feels vast but calm. The listener is left with a sense of belonging to the very chaos that once seemed terrifying. And as the voice fades to a whisper, it leaves one lingering question in the dark, gentle, uncertain, and human. If storms from distant suns can someday touch us, shaping the world in ways we cannot see, how should we live beneath such an endless sky? The silence that follows feels like the universe itself pausing to listen. The story opens under a sky that feels infinite yet strangely small, an ocean of stars scattered over sleeping cities. The narrator's voice is soft, steady, and low, as though speaking from the edge of the world. Every night, it says, we think we're watching the sky. But really we're only watching the parts we can see. The scene drifts across quiet observatories, domes turning with slow grace, motors humming in the dark. Wide-field cameras capture faint pinpricks of motion, small dots sliding between stars. From high deserts to mountain plateaus, the air is thin, and the world below seems to fade away. Here, astronomers do not shout their discoveries, they whisper them. The night belongs to patience, to long exposures, to trust that the cosmos will reveal something new. Above them, in orbit, other eyes watch too. Space-based telescopes drift like silent guardians, free from clouds and atmosphere. Each one listens to starlight with careful attention, translating every flicker into data. The narrator explains simply, these instruments work like memory itself, collecting, comparing, searching for something that wasn't there before. In the background, a faint tone of curiosity lingers, like static from a forgotten signal. The story describes the new generation of survey projects, vast digital mosaics of the night sky built frame by frame. Each night they photograph billions of stars, looking for movement, A dim comet emerging from the edge of a frame, a near-Earth asteroid crossing a constellation, a flicker from a dying star. To a human eye, the change would go unnoticed. But artificial intelligence, trained on countless images, can see a drifting shadow between two exposures and whisper, "There. Something moved." Automation has become the heartbeat of modern astronomy. Machines remember what skies looked like last night, last week, last year. They compare, pixel by pixel, searching for anomalies, an object with an orbit too fast, too slow, or too strange. The narrator's tone stays calm and almost musical, describing these systems as if they are dreamers themselves, quietly watching the dark more closely than we ever could. Beneath that calmness, there's humility. The narrator reminds the listener that even with our best technology, the universe still hides more than it reveals. Every discovery, the voice says, creates a larger shadow of what we don't yet know. Telescopes may grow sharper, their mirrors wider, their sensors colder and more sensitive, but space remains endless, and our field of view remains a thin keyhole in an infinite wall. The tone softens further, becoming more human. In the observatory control room, a scientist watches a monitor where stars glide across the screen. The computer highlights one point, a pixel dimmer than before. "It could be a rock the size of a bus," she murmurs, "or just a software glitch." She marks it anyway. Somewhere in the data, there is always something small enough to be missed, something just beneath the noise. The narrator draws a parallel between cosmic vigilance and human perception. We learn, it says, that seeing is not the same as understanding, and that even the clearest image can hide what matters most. The hum of machinery fades into the whisper of the wind outside the dome. The stars seem closer now, as if leaning down to listen. AI has changed how we look at the sky, but not what we feel when we look. The machines detect, but it is the humans who decide what is worth watching. That decision, the narrator continues, is the heart of our challenge. The problem isn't only in detection, it's in reaction. How do we choose what to fear, what to follow, what to ignore? The gentle sound of typing, clicking, the rotation of telescope gears fills the background, steady as a heartbeat. Then a subtle shift in tone, hopeful, almost tender. The narrator describes cooperation across continents. Data shared between nations, signals verified by distant labs, sky surveys stitched together like a single cosmic quilt. For once, humanity seems to move in rhythm, looking outward instead of inward. There's beauty in that, countless individuals connected by curiosity, tracing orbits and anomalies that drift through shared night skies. A quiet image unfolds of satellites circling Earth like glowing beads on a thread. Below, oceans mirror faint light. In the calm of night, our planet looks peaceful, small but aware. The narrator speaks softly, we are learning to see ourselves from a distance. And from that distance, perspective grows. As the chapter nears its gentle peak, the story balances wonder and humility. Technology gives us reach, but also reveals how little of the universe is ours to claim. Every newly mapped object, every comet, every drifting traveler, reminds us of what still lies beyond. The bigger problem, the voice says, is not blindness but impatience. Our struggle to look long enough, together enough, to make meaning of what we see. The chapter slows, its rhythm easing into reflection. Perhaps the greatest telescope, the narrator muses, is time itself. The more we wait, the more the universe reveals. But patience is rare in a world that measures discovery by the day. Soft music fades under the words. The sky is described again, this time through the eyes of someone listening, someone lying awake looking through a window. The stars shimmer faintly, and somewhere above, a camera captures that same patch of darkness. The listener is invited to imagine. Maybe tonight, one of those observatories will notice a flicker no one expected, a moving light against the whisper of stars. The narrator's voice grows quieter now, nearly a whisper. When we look more closely, it says, we find motion where we thought there was stillness. We find connection where we thought there was silence. The dark is never empty, it's only waiting. The chapter closes with a final image. A telescope dome rotating beneath a field of constellations, its lens glinting briefly in moonlight. The hum stops. The stars keep drifting. And in that infinite stillness, one can almost sense that another secret, some small, beautiful truth, has just begun to move. The night begins the same way it always has, quietly. A dome of stars turns above observatories and rooftops, over mountains and sleeping towns. In one corner of the world, a scientist sits alone before a glowing screen, eyes fixed on a stream of light from a distant telescope. In another, a child leans out of a bedroom window, making a wish on a falling meteor that will never be seen again. Between them lies a connection older than language, the silent curiosity that binds every watcher of the night sky. The narrator's voice is calm, like a soft wind through grass. It explains that for all the vastness of space, the galaxies, comets, and drifting anomalies, the true wonder lies in how small we are, yet how persistently we look upward. Each observation, each whisper of data through a spectrograph, is a reflection of a question older than civilization. What is out there, and what are we within it? At midnight in Chile's Atacama Desert, radio dishes sweep in synchronized arcs, listening for cosmic whispers buried in the static of time. On the other side of Earth, an engineer in Tokyo adjusts the calibration of a deep space antenna. The narrator's tone slows, describing the soft hum of machinery, the quiet pulse of a screen. There is something almost sacred in this routine, thousands of people, half asleep, chasing faint glimmers across a cradle of silence. It is work that requires patience measured not in hours but in generations. And yet, the chapter reminds this search is not only about science. It's about belonging. Every comet we name, every exoplanet we chart, every orbit we trace. These are fragments of a story we're writing together. When scientists study the faint shimmer of an exoplanet's atmosphere or track the dusty tail of a comet drifting through perihelion, they are also mapping the edges of human wonder. The data points become memories, and the discoveries become part of the collective dream. Soft transitions guide the listener to another scene. A control room in Hawaii where the sky is perfectly clear. A researcher leans closer to the monitor, her voice low. We've got movement. A pixel shifts, a new object emerges, and suddenly the universe feels alive again. The narrator invites the audience to imagine that moment. The thrill of discovery, the heartbeat of realization, the sense that something vast just revealed a tiny secret. Then, the tone cools into reflection. Every detection, no matter how small, is a reminder that we are participants in something greater than survival. We are caretakers of awareness itself. Children around the world gaze at the same stars. In villages without electricity, people trace constellations with their fingers. In cities, people look up between skyscrapers, catching glimpses of Venus or the moon through smog and light. Even astronauts aboard the International Space Station, orbiting at thousands of miles per hour, press their faces to windows just to watch sunrise from above the world. The narrator ties these visions together in a slow, cinematic thread. We are all looking at the same sky, just from different corners of the dream. Then comes the quiet turning point, the bigger problem the title alludes to. The narrator lowers its tone, almost to a whisper. Despite our shared fascination, our vigilance is uneven. Many observatories struggle for funding. Some telescopes go dark because the electricity bill cannot be paid. The cosmic web we depend on to understand the universe is frayed by politics, budgets, and short attention spans. The real danger, it suggests, isn't an asteroid or comet. It's forgetting to keep looking. The imagery grows more intimate. A scientist filling out a grant form under flickering lights. A data analyst spending long nights verifying an orbit no one else has time to check. A classroom globe turning under the fingers of a child dreaming of Mars. Each small act of curiosity, the narrator says, is a defense against the silence that could return if we stop caring. Knowledge, like starlight, fades unless someone keeps the telescope open. Soft ambient tones drift in the background, wind, the faint ticking of instruments, a low hum. The narrator draws a gentle parallel. We build instruments to catch faint signals, but we also need instruments of empathy, to listen, to share, to remember that science is a language spoken best when it's collective. A single astronomer can trace an orbit, but humanity as a whole must decide what to do with that knowledge. The bigger problem becomes a shared human challenge. Not seeing the universe, but sustaining the act of seeing. The perspective widens again. The narrator describes a slow, panoramic sweep over Earth at night. Continents glowing softly beneath networks of light, oceans dark and vast. From space, it says softly, humanity looks like a shimmer of bioluminescence, a fragile pulse against the black. Each light below marks someone awake, thinking, building, or watching the same stars. In that fragile pulse lies a pattern, the human thread woven through the cosmic web. The story pauses. You can almost hear the stillness between stars. Then the narrator speaks directly, its tone barely above a whisper. Maybe the universe isn't something we observe from the outside. Maybe it's something that observes itself through us. The silence stretches again, inviting thought. It explains how, through telescopes and satellites, we've become the eyes of the cosmos looking back upon itself. Every orbit measured, every anomaly noted, every meteor traced. These are the universe's way of remembering its own story. And in this memory, humanity is not the center but the mirror. The chapter begins to soften toward its end. The imagery turns inward. A child now asleep, the meteor gone, the scientist closing her laptop, the telescope dome sliding shut. The hum of machines fades into the whisper of wind. The narrator's voice grows quieter, more intimate. We watch the sky, it says, but the sky also watches us, through the glow of our cities, through the reflections on our oceans, through the fragile breath of our atmosphere. We are part of the pattern even when we forget. In its final moments, the narration lingers on a vision, the earth turning slowly beneath a field of stars, each rotation a heartbeat of time. The question that closes the chapter arrives gently, almost like a lullaby. If the sky belongs to all of us, how do we choose what to look for next? And with that, the sound of distant starlight fades, leaving only a quiet hum, a reminder that even in rest, the search continues. The sky above is a cathedral of quiet motion, dust, gas, and light weaving stories that unfold too slowly for a single lifetime to see. Somewhere beyond the clouds, comets drift on fragile threads of orbit, their icy bodies carrying memories older than Earth's first breath. When they swing close to the sun, a transformation begins. The ice boils into vapor, the dust shines, and the darkness behind them blooms into a luminous veil. To the untrained eye, it's a spectacle. To astronomers, it's a script written in cosmic handwriting, each shimmer, each curve of trajectory, a clue to something deeper. For centuries, humanity read omens in the heavens. A sudden streak of light once meant the anger of gods or a sign of change. Today, our telescopes replace superstition with data, yet the instinct remains, to seek meaning in motion, to ask what these celestial wanderers are trying to say. The modern version of prophecy lies not in fear but in decoding. In the faint traces of starlight and dust, we glimpse messages written across time, warnings perhaps, but also possibilities. The chapter opens gently on this truth. Comets are not mystical heralds but scientific messengers. Their orbits record the past, and their tails, trails of dust and ionized gas, forecast the future. A small change in one path can ripple through centuries. The solar wind's invisible breath pushes against them, reshaping their courses by imperceptible degrees. A few thousand years later, that adjustment could mean the difference between a comet that passes harmlessly, or one that threads between Earth and Moon, glowing brighter each night until its soft tail arcs across the horizon. Scientists trace these patterns with quiet precision. Each observation is a verse in a vast poem of numbers. They watch for anomalies, minute shifts in brightness, erratic turns in orbit, new spectral lines appearing where silence once was. A spectrograph catches it first, a streak of light decomposed into color, split into hidden codes. There, in the violet end of the spectrum, something changes. A spike. A dip. An unknown emission. It's not magic, it's chemistry, temperature, movement. Yet in the language of science, this is how the universe whispers. In a quiet control room, an astronomer sits before a glowing monitor. Lines of data scroll like an ancient scroll unrolling under electric light. She adjusts the lens, calibrates for noise, and looks again. A comet's trajectory has shifted slightly after its last perihelion. Nothing dramatic, just a deviation so subtle that only a decade of records could reveal it. But in space, small deviations grow. The sun's heat expands one side more than the other. Jets of vapor act like invisible thrusters. The comet begins to drift off its predicted path, a slow rebellion against the mathematics that once defined it. This is prophecy made of dust. It is not fortune-telling, it is foresight built from patience and pattern. Every object in the solar system holds potential energy in its orbit, waiting for gravity to write a new verse. The challenge is to read it before the moment of revelation. Humanity, for all its technology, still depends on these faint clues. A ripple in starlight, a reflection in a telescope's glass, a line in a data table. But the story is not about danger alone. There is something hopeful hidden in this vigilance. For every unknown traveler that slips through our gaze, there are dozens caught just in time. Telescopes like Pan-STARRS and the Vera Rubin Observatory now sweep the heavens nightly, capturing terabytes of images, each pixel a possible messenger. Machine learning algorithms hum softly, comparing frames, seeking what the human eye might miss. In their silent rhythm lies our growing awareness. Imagine for a moment, a warning discovered early. A faint object appears, a tiny dot near the sun's glare, moving differently from background stars. At first, it seems nothing, a drifting shadow. Then its orbit is refined, its approach confirmed. The world holds its breath. Yet because it was seen early enough, there is time. Time to study, to plan, to act together. There is no panic, only preparation. In this imagined prophecy, science fulfills the role that myth once did, not to frighten but to forewarn. It is this sense of anticipation that defines the era we live in. Not dread but readiness. The instruments of our age, the telescopes, the spectrographs, the radar beams, are not shields but eyes open wide. The universe, vast and indifferent, continues its motion, and we, fragile as we are, have learned to listen. Still, there's humility woven through that listening. The more we see, the more we realize how much remains hidden. Between the bright streaks of known comets and the distant glow of galaxies, there is darkness, thick, patient, uncharted. Somewhere within it, more stories wait to be told. Perhaps fragments of long-collapsed worlds, carrying the chemistry of forgotten suns. Perhaps something that once belonged to another system entirely, now wandering in exile through the interstellar dark. The narrator's tone softens, like a voice lowering near the end of a bedtime tale. Prophecies, it says, are only as powerful as our willingness to believe in them, not as fate but as guidance. The dust that drifts in a comet's wake may someday settle on another world, becoming the soil of life yet unborn. The light we see from a distant explosion might be the echo of creation itself. The future is not written in stars, it's written in how we interpret their glow. There's a subtle peace in that realization. For all our fragility, we are capable of awareness. We can see, measure, and wonder. We can learn from patterns older than civilization. And in doing so, we've begun to transform fear into knowledge, chaos into meaning. As the chapter fades toward silence, the narrator returns to the theme of choice. In every discovery, every faint signal, every anomaly, there is a question that mirrors our own reflection. What story do we tell about what we find? Do we see doom in every comet, or connection in every orbit? Do we respond with panic or with preparation? The difference between the two defines the kind of species we become. The final words drift like starlight dimming behind a passing cloud. Somewhere beyond the reach of any telescope, countless objects move unseen, carrying their secrets in cold silence. Some will never cross our sky, others will. But for those who watch, the sky will always speak, through dust, through light, through the faintest of whispers. And in that whisper lies a quiet promise, that the act of looking upward is itself the oldest prophecy of all. A fragile species on a small blue world, daring to find meaning in the motion of the stars, listening still for what the universe might one day choose to tell us. The night unfolds like a deep breath, slow, steady, endless. A single person lies in bed, the room dim except for the faint reflection of moonlight brushing across the ceiling. Outside, the world turns quietly beneath a sky of drifting shadows and soft glows. Somewhere above that ceiling, beyond the thin veil of atmosphere, telescopes hum and listen, eyes of glass and mirrors watching what the human eye cannot see. Every second, the planet moves through a river of dust and light, its orbit steady, its travelers, comets, asteroids, and invisible fragments, passing silently in the cradle of darkness. The narrator's voice lowers to a gentle murmur, recounting how the journey began. With 3I/Atlas, the interstellar comet that shimmered like a visitor from another age. It was a reminder that not every traveler in the solar system belongs to us, that sometimes, what drifts near the sun is a messenger from beyond. We followed its path through telescopes and spectrographs, tracing its trajectory as it curved past the planets, its luminous haze fading back into the black. But it wasn't the comet that mattered most, it was the realization it brought. In the quiet after its passing, scientists began asking harder questions. How much do we really see? How much escapes our instruments' reach? Behind every bright visitor like 3I/Atlas lies a hidden chorus of smaller, darker ones. Asteroids faint as dust, meteors no wider than a house, each following its secret orbit. Some are watched. Many are not. The bigger problem, the narrator explains, isn't one object or one event. It's the shadow between our glances, the gaps in the net of attention stretched around our world. The voice drifts, calm and reflective, describing those blind spots, places where the sun's brilliance hides potential threats, where telescopes cannot peer without being blinded by the glare. In those regions, anything could move unseen. A fragment of ice, a stone traveler, even something unknown, gliding through the light like a whisper lost in conversation. We build our instruments, the narrator continues softly, but the universe has its own rhythm. It speaks slowly and sometimes we are too loud to listen. The tone eases into warmth, turning toward the human story. There are men and women awake at this hour, Astronomers, engineers, programmers, staring at data on glowing screens, watching dots shift pixel by pixel. In observatories perched on volcanic mountains or floating far above the clouds, they track faint traces of motion that might never make the news. The sound of fans, the gentle buzz of servers, and the soft tap of keyboard keys form a kind of nocturnal symphony. It's not fame that drives them, but something simpler: curiosity and the quiet duty of keeping watch. Down on Earth, millions sleep beneath that same monitored sky. Some dream of stars, others never think about them at all. Yet all of them are part of the same fragile sphere, shielded by atmosphere and magnetism, protected by a thin line of physics that deflects the solar wind. The narrator's voice describes the auroras, curtains of light swaying at the poles, born from those magnetic battles between charged particles and air. To some they look like prophecy, to others like music made visible. Either way, they are proof of the invisible work always happening above us, defense through beauty. As the chapter continues, the story shifts between awe and tenderness. The planet's shields are strong but not perfect. Asteroids still wander too close. Solar storms still reach through. And yet, despite it all, life endures. The oceans breathe. Forests sway. The lights of human cities pulse faintly like constellations turned inward, reflecting our need to imitate the stars. We've learned to map what we can, the narrator whispers, but what holds us steady is faith in the watchers, the ones who stay awake, measuring shadows while the rest of us dream. The pace slows further now, almost to a lullaby. The person lying in bed shifts slightly, pulling the blanket closer. Through the open window comes the faintest sound, a night breeze, the distant hum of a streetlight. Above, unseen, satellites glide in silent formation, their solar panels catching glints of sunlight even in darkness. Some track weather, some track stars, some simply listen. Together they form an invisible network, a modern constellation of guardians built by human hands. The narrator's tone turns reflective, almost meditative. Every generation believes it's the first to truly understand the sky, and every generation is proven wrong. What we learn instead is humility, that in every equation, every photograph, every fragment of orbit data, the universe remains larger than the numbers suggest. That's the beauty of it. We are not meant to finish this story, we are meant to pass it on. Moments of silence stretch between sentences now, like breathing space between waves. The voice becomes softer, inviting rather than instructing. The bigger problem no one is talking about, it says gently, was never danger alone. It's the forgetting that beyond our walls of noise and light, the universe is alive with motion. We are not just observers, we are participants woven into the cosmic tide that keeps the stars turning. The listener is asked, not commanded, to remember the quiet work of those who watch the sky. To support curiosity, to look up once in a while, to listen for the whispers carried on solar wind and cosmic dust. These aren't tasks of fear but of belonging. Because, the voice continues, the moment we stop watching, the moment we stop wondering, is the moment the story begins to fade. And stories are how we stay connected, to the past, to each other, to everything beyond. The final minutes slow to near stillness. The narration fades into imagery, starlight spilling like soft water, the turning of Earth beneath a tapestry of quiet signals, radio waves, and the low hum of telescopes in the dark. The cradle of silence becomes complete, wrapping both listener and planet in the same calm vastness. And then, barely above a whisper, comes the closing line, "Tonight as you drift into sleep, remember this, even now as your heartbeat slows and your thoughts dissolve into dreams, the sky is being watched. Somewhere, someone is listening to the stars. And in that listening, the mystery continues."